All right. So, title of my presentation is going to be called "Your Password Policy Sucks." This presentation kind of came out of last year. I did some real technical presentations on a tool called Oclhashcat, and a lot of people mentioned that I skipped a big part in the beginning, and that was kind of basic usage and how I arrive at the way that we use things. And so I'm going to kind of maybe go backwards this year with this presentation and hopefully show a little bit about this stuff. Who am I? I'm a security consultant at Examp. Consultant's a nice word for hacker. I'm a core developer for Backtrack Linux. Anybody ever heard of Backtrack? Yes? No? Look, and just in case my presentation sucks, is that going to work? Backtrack 5, you saw it here first. That was called a teaser. Anyway, I'm also a founder of a website called QuestionDefense.com. We do technical questions, technical answers. Some are really stupid, like how to turn on my monitor, and some of them are really complex, like pen testing type stuff. So me and my friend Alex, we do it for fun. It's a lot of fun. I'm also a co-founder of DerbyCon, which is a convention that's going to be in Louisville, Kentucky that me, Adrian, and Dave Kennedy are putting on. And that is the last weekend of September, first weekend of October. And most importantly for this presentation, I was the member of the team that won the password cracking contest at DEF CON this year, or last year, I guess. I'm trying to get it together. Anyway, so this company called CoreLogic put on a contest called Crack Me If You Can. The basis of the contest was you could have as many people as you wanted on your team, and there were 60,000 hashes, and whoever could crack the most of them in 48 hours. And so me and my team won that competition, and that's kind of the other reason that I was doing this talk, is a lot of people wanted to know exactly the methodology that we used in order to crack those lists of passwords. Work? So my disclaimer is I'm not a password expert. I don't know everything. I'm frequently wrong and slow to admit it. And I'm not responsible for what you do with any of this information. So the things that I want to cover are why are passwords still a vector of attack. One reason is people are always saying, you know, passwords went out 4 or 5 years ago. As soon as we made passwords over 8 and 10 characters, tools like John the Ripper became useless because it takes so long for CPU-based password cracking. And so we'll talk about later some of the techniques that have come back that have brought passwords back. Companies still have bad password policies. I'm going to talk a little bit about those. I'm going to analyze a few of the recent most password breaches and go over a little bit of the information, why those breaches are so valuable. If you're ever on Twitter or on IRC when one of those breaches happens, you'll notice that you know, a lot of people in the password cracking community will be in a hurry to get those lists as quick as possible before companies like Pastebin take them down. Talk about the reason for why we want those. And some of the advancements in password recovery, and then the tools and techniques to crack passwords. Obviously, I'm biased to Hashcat, but there's a lot of new tools that have come out in kind of the Hashcat suite. And we'll talk about some of those. So what's wrong with passwords? They are the weakest method of authentication. Password authentication is just terrible. But unfortunately, we're stuck with it. And so what can we do to make we're going to talk a little bit about what can we do to make that password authentication better. Obviously, a lot of companies have gone to two-factor authentication, although if you've been paying attention to the news in the last 2 days, your RSA key might be useless. Many websites, and this is particularly true of websites, not necessarily internal networks, but websites are notoriously bad for bad hashing algorithms. You know, 5-10 years ago, websites were getting blasted all over the place for storing passwords in clear text. Now they're still storing passwords with weak hashing algorithms. The other thing about passwords is humans are predictable, and I'll talk about that a little bit later, but like when you're sitting at your desk at your company X and you're making up your password, 9 times out of 10, you're going to be looking around the room and you're going to see something that has to do with company X, and that's going to be the root of your password. And you may add some uppercases and special characters and that kind of stuff, but many, many people will make their password specific to their environment. And then with the use of GPU password recovery, it's become pretty much a joke to crack a lot of password algorithms. So you're saying to yourself, my company's got a password policy, we're good. That's great. However, what I'm going to show is that knowing the password policy of a company can actually help the password cracking. If I know that your policy, and I'm jumping the gun here, I'll get into that in a minute. And some organizations impose really limiting password policies. I'm going to show you a real world one that I actually found. And the worst thing of all is that many companies never ever change the default Windows Active Directory password policy because they feel like it's good enough. That's easy to figure out. So here's a real world example. I blacked out the name of the company not to embarrass them. However, this is a real world password policy that I actually found on the internet. And so if you look at it, let's go through it. Your password policy is case sensitive. That's fine. It cannot contain any special characters whatsoever. That's a little bit limiting. It can't contain your username. Well, that's sort of a good policy. It can't contain two separated numbers. I mean, is that not the most ridiculous thing you've ever heard? So that means that your numbers cannot be separated anywhere in the password. They have to be together. And then it can't contain company name or password.
How do you do that?
Yeah, I'm not sure. This was a website, so I'm not exactly, I'm assuming this is some homegrown coded application. This is just some policies. I was honestly trying to find the worst policy that I could. This is what I came up with. So this is wrong on a lot of levels. So there's a 10-character maximum, so that's a failure all by itself. Anything under 10 characters is easily crackable. No special characters. So the US keyboard has 94 typable characters, and 32 of them are specials. So if we eliminate those 32 characters, we've eliminated 1/3 of the possible password characters. And then numbers can't be separated. I still can't get my head around that. I'm not exactly sure how that happened. But anyway, so if you worked at my company, which is Ocalhashcat, you might come up with some of these passwords based on this password policy. So in the beginning, I got this really common one, which would be one letter's got to be capitalized. It's always going to be the first letter because it's easy to remember. And you might need to append some digits to the end. It's going to be a date, like the date I was born. You know, and then you go down the list here, and so at the bottom I have, with this particular password policy, this is the best possible password that I could come up with. And it's still not that great of a password because it's only using 66 of the 94 or 64 of the 94 character sets. And so, and it's got a 10-character maximum. Using some of the tools we're going to look at later, that password would easily be broken in an hour. And so if that's the best possible password this website can come up with, you can imagine what all the rest of them are like. All right, so when I talk about the patterns that people make password choices on, this is really important because when you're on a pen test, and I'm talking legally here, it's important to kind of profile an organization. And what I mean by profile an organization, I mean like downloading their entire website, turning it into word lists, downloading the city that they're in, the sports teams that are around there, you know, that kind of thing. If it's a religious organization, we might want to, you know, make a word list out of their, what do you call it, Bible or special book or whatever they got going on. And so when people make passwords, they'll almost always look around them. And I'm not just making these things up. This is from personal experience on pen tests, looking at analyzing the passwords from companies and seeing how many of them actually have company name somewhere in them. Numbers are almost always going to be in a date format, 11 or 2011. If the password policy requires a capital letter, it's almost always going to be the first letter. And if the password policy requires a special character, it's almost always going to be at the end. So Here's another policy, and this is the type of policy that I see in place almost everywhere that I go. So your password must be at least 8 characters. It must contain 1 uppercase letter. It must contain 1 number, and it must contain 1 special character. Right? Sound familiar? People got policies going on like that? Well, the average person, like I said, is going to capitalize the first letter, choose a word, choose a meaningful date, and choose a random character, and most likely they're going to come up with something like this if they work at my company. So you're thinking my passwords are leaked. And that may be true. Everybody in this room might have awesome passwords, but that is not true in the real world. And so you got to keep in mind that when we're auditing companies, we're talking about average people. And so, like I said, these presumptions are made from my personal experience. And it's also been my experience that most companies are not interested in security until they experience some type of hack. All right, so this bad password policy happens for a couple reasons. One of them is lazy network admins, which accept the default Windows Active Directory policy. It can be changed. The worst offender, I think, is badly coded applications. What I'm assuming, that very first policy that we looked at in the beginning that didn't allow special characters, what I'm assuming is that whoever coded that application sucked, and he was not able to create a password validation field that would take special characters. And so instead of learning how to code properly, they just decided to fix their policy. And I can guarantee you that that company is going to pay for that mistake. They might have saved a little bit of money on the application, but anyway, another major reason CEOs complain. CEOs, as you know, run the companies, and so if they complain, they don't want to enter in some big, long, crappy password. They complain, and they're your boss. The network admins have to fix the policy to suit the CEOs. And another big reason is that companies don't have regular password audits. In my experience, even with all these password policies in place, it's always a good idea to just dump your password hash list in your company and have it audited by a third-party company. And then, because even though you have a strict policy, people are still going to make those patterns based on those passwords based on patterns. So if you audit passwords, you can go to those users 1, 2, 3, 4 times a year and say, hey, we know your password followed the policy, but it sucked, it was predictable. And eventually those people are going to get tired of you coming to them and they're going to choose a better password. Nobody likes visits from the IT security department. All right, so we're going to talk about how we can leverage this info in a pen test. So what I like to do is analyze current real-world lists. You know, those password lists that are up on, what's that, Packet Storm or something that have been, you know, like Unix-based passwords that were hacked in 1999 or something like that. Those are not valid anymore. You know, those are not good for much. Yeah, they're dictionary words, but most applications and companies have kind of gotten over those type of passwords. Anyway, they can still be useful as what I like to call root passwords, which I'll talk about in a little bit. And so analyzing the patterns from these lists, from the new lists, is what can help us to leverage against new passwords attack. And the main problem is that people tend to use the same or similar passwords across all their internet accounts. And so here's a little graph of I'm trying to show if I know what the policy is, how much quicker I can brute force the password. So at the top, I got a 7-character password, and I don't know anything about it. So that means I got to try 94, 94, 94. It's actually 94 times 94 times 94. Anyway, I'm pretty sure my math is right, but if it's not, don't kill me. But so anyway, if I was to brute force that 7-character password at 250 million passwords per second, it would take me 72 hours to get through the list of all the possible combinations. So that's kind of a long time. It's not.
Well, but then with the birthday attack, you're really only going to have to do a day and a half, though, right?
With the what?
Birthday attack. Well, what is it? It's the thing where it says you typically only have to go through half of a list to actually get the.
Correct. I mean, it's possible. You know what I mean? You might get a fourth of the way through the list. You might get a third of the way through the list. I mean, it's kind of debatable. You know what I mean? It all depends on what application you're using to brute force it and how it goes through the combinations. This is just the worst case scenario type of thing. So yeah, it might not take this long. Okay. So, but if I'm aware of the password policy, and I know that there's got to be an uppercase letter, and there's got to be a special character, and there's got to be some digits. Based on some of that information I found before, the first character I only got to try 26 uppercase. The next couple characters I only got to try 26 lowercase. The next two characters I might only have to try the 10 digits, and the last character I might only have to try a special. And so that would cut, in this particular situation, my attack time down to 6.21 seconds at 250 million passwords per second. And so, somebody, question?
Can you take questions?
Yeah, go ahead.
What's the hardware behind that 72 hours?
Well, honestly, I just made up the 250 million for the math, but I can go through a little bit of the hardware at the end. John the Ripper, I think, does about 1 million or 2 million passwords per second, maybe. And I got a graph in just a little while that will show some of the GPU-based type stuff. But for the most part, with like one average video card, like a NVIDIA 295 GTX, you can get about 300 million passwords per second. So pretty much any gamer that has a spare video card can do this, which is bad. All right, so here's what I consider the top breaches of the last couple of years. And so this is just an example of the weak hashing password algorithms that are out there. Everybody remember RockU? RockU, yes. Anyway, so their breach consisted of, let me get this number right, 14 million something or other passwords, and they were all hashed in MD5, which is a really bad algorithm because it does not require a salt. Salted passwords are a little bit better. I'm sure everybody remembers Gawkers. Gawkers had 67 million passwords, which were in DES, which is such an old algorithm that our GPU-based password crackers can't even do it because of some hardware level type of thing, but we still managed to crack that many of them, even with John the Ripper. PHPBB, which was a big form board anyway, they had a big leak, 18 million MD5s. eHarmony just recently had a giant breach, 224 million MD5s. And then, I'm not allowed to say the name of this site, but anyway, so they also had a breach of 38 million MD5s.
You mean Wachovia?
No.
Bank of America, right?
No.
You're not going to tell us if we
Once again, I'm not allowed to say the name of the site.
But if we confirm.
No.
Can you look slightly to the left?
Anyway, so the reason that we have these lists is because these are an absolute goldmine of information, because these are real live passwords that people are using, and I can guarantee you that, you know, some lady on eHarmony that's trying to find a date used the exact same password for her bank account, and you can guarantee it. But the reason that might be a nefarious reason for wanting these lists. The reason that we want these lists is for patterns. You know, I'm looking for stuff like, are people separating words with special characters? You know, for example, like, is that a new pattern that's emerging? So the things that we can learn are the most common password lengths, which are important, the most common character sets, the most common masks, and I'll tell you what a mask is in just one second, and the frequency of root passwords. What I mean by the root password is if you take away all the uppercase and the leet and all that garbage, you're left with what's called a root password. And so that's really all that we're concerned about, because as we'll look at later, we can apply all these rules to a root password. And instead of having a word list that's 5 quadrillion gigabytes, we can just have a little bitty word list and a lot of effective rules. And so that's the way that we attack passwords nowadays. All right, so when I'm talking about password masks, what I'm talking about is replacing all the lowercase letters with $L, uppercase $U, numbers $D, special characters $S. There's also a $H for hex characters, but have never used it, and I don't want to put it up there and confuse anybody. So going back to my password that I had before, because I work at AccuVant, and I was, you know, it's year 2011, and I thought this would be a good password. So my mask would look like this. So that doesn't make a lot of sense right now, but it will in a second. So if we do some analysis, I'm not going to do all the whisks. I'm going to do ROC-U, and then I combined all the rest of them. So if we analyze the ROC-U list, we can see the first thing we want to look at is the line count statistics. And this is how many characters the passwords were. It doesn't matter if they're upper, lower, special, or anything like that. We want to look at how many characters. So we can see that 20% of them are 8-character passwords. So when I complete my first attack against a current password list, I'm going to use 8 characters as the first, that's going to be my first baseline, because 20% of 14 million being 8 characters is a lot. And then you can see the next one down is 7, the next one down is 9, 10, and so on. And so based on number of characters, this is the attack my methodology is going to go into. And there's no one specific special attack against a password list. You normally have to do multiple things, which we'll kind of look at later, to kind of whittle your list down one at a time. So the next thing we want to look at in the statistics of the ROC-U list is we want to look at the character set statistics. And so we can see that 42% of the passwords are lower alphanumeric, meaning all they used was lowercase characters and numbers. So that is close to half. So now, armed with these facts, now I know that if I do an 8-character attack with numbers and letters, lowercase, I'm going to get almost 50% of the passwords. So the next statistic we want to look at is this particular tool. What it does is it outputs the masks. Remember the masks we were talking about? So it outputs the masks in lower, upper digits. And so something interesting that you can see in these top 10 or 15 or however many masks there are is that there are no U's. There's no uppercase at all. So what that tells me is that people are not using a lot of uppercase letters in real-world passwords. And so you can see that the most popular mask was 8 lowercase digits, which we already determined from some of the other stuff. But so this type of thing is useful because once you start adding up lists and lists, you can start seeing what the most common masks are. And so keep in mind this is only one list. All right, so what I did here was I analyzed, I put all those password lists of those top 5 breaches together, and I did a little bit of analysis. And so basically this is telling me the exact same thing that I already knew, is that 8 characters is the most popular line count, and lower alphanumeric is the most popular character set of passwords. So, and then what I can do is I can get my top 5 masks out of here. And these masks like this work in Oclhashcat and Hashcat, which is why I use these masks and why we made this tool to do this. So these are the first 10 or 12 attacks that I'm going to try against any password list. I'm not even going to get out a word list because I don't need one, because I know that these are the patterns that humans are doing right now. All right, so how does all this info help us? It eliminates the needs for large word lists because these mask attacks do not require a word list. It's basically a brute force, but it's only a brute force of the character set that you place in there. So if you put an L, it's only doing a brute force of A to Z lower. Like I said, these masks can be used with Oclhashcat. These masks allow us to profile password policies. And so every time we analyze a new breach, we get more info for our attacks. The way that I can profile a password policy is I might go into a company and I might dump the hash database, and I might only crack 5% of the passwords with my initial brute force. However, what I can do is then analyze that small list of passwords, and while looking at it, I can 9 times out of 10 determine the password policy of that organization, and then I can retailor my attack just to that password policy. Yes. Yeah. Basically, I would just redo the masks to match the policy. And like I said, there's no one all super inclusive attack. I wish there was. But sometimes you got to try 8 or 10 or 12 different masks. But they will, you keep whittling away at the list. Eventually, you'll get enough of them. And I'm actually, I had a video that was awesome, but we can't see it. But I'm going to try to explain the attack. But anyway, so here's kind of my methodology. And this is the methodology that we used in the contest. This is what a lot of people were interested in. The first thing we did was we brute forced all the lists for up to 5-6 characters based on our GPU hardware. That really only took about 10 or 15 minutes. And so that gave us our initial list where we started to look at the patterns. The thing about this contest that was a little bit different that I got to mention is that it was not really real world. Those guys at CoreLogic are password cracking champions, and they made this contest as hard as they possibly could. And so some of these real world patterns that I'm talking about weren't in there. However, once we started looking at their list, there were some patterns that they inadvertently did. And so, because what they initially did was they used John rules to create their list. They had a base list of words, and then they used rules from John and created the list. So once we figured out what some of those rules were, we got a little bit farther. The next thing I would do is word list attacks. I would do straight word lists. I do not keep thousands and thousands of gigs of word lists. I think I might have 5 gigs max of word lists, and they are useful, but they're more useful with rules, which is what I'll get to later. Then I would go into all my mask attacks that I came up with all my, profiling policies. Then I would do what's called a combination attack, which is what we'll look at an example of that in a minute. The next thing that I would do is the new version of Hashcat has the ability to create rule files similar to John the Ripper, but they're a little bit more sophisticated. So I would build a policy inside one of those rule files. And then the very last thing I would do is something that we talk about called a fingerprint attack. And that's what the video I was going to show was, but you can't see it up here, but I'm going to try to explain it even though it's tough. I was going to do it live, but I seem to be having some internet issues that are Verizon's fault. Yeah, I'll be sure to hook up to the hotel Wi-Fi.
Oh, use mine.
Yeah. So I threw this in there because this is like a graph of how we progress through the contest. If you'll notice, just to reiterate how hard the contest was, I mean, there was 10 people, experienced super password crackers on my team, and we only got about 38,000 of the 60,000 passwords, or maybe there was 58,000, I don't remember. But you'll notice that you can see how we climbed really quickly in the very beginning when we brute forced some passwords. Then when we started to use all our mask attacks and our word lists and everything, we made a little steady climb. But then you can see right around 30,000, we kind of hit a plateau. And that was the point where we had to go in and start analyzing the list and figuring out the patterns about, doing it a little bit more sophisticated than just running tools at a password list. Because we had the inside pro guys who are Russian professional. They make a commercial software tool, and it's my understanding they have racks and racks and racks of servers password cracking. They were actually hot on our tail. They were right behind us the entire contest. And so it was at this point that we had to really kind of get down and figure out some password patterns, which we did. And so what that shows, though, is that password cracking is more of an art. It's not just slamming tools into the list and getting as much as you can, even though that's what a lot of people do. If you really want to recover a lot of passwords, you got to kind of dive into the patterns. All right, so using the GPU to crack passwords. This is huge. This is what brought password cracking back, in my opinion. At this point, passwords under 8 characters are pretty much a joke. Excuse me. With the hardware we have now, we can brute force 8 characters in less than a few hours. It's just ridiculous. And the difference between that is most modern desktops have about 2 to 12 cores, depending on how much money you have, or a gamer, or whatever you're doing. And so if you think about each of those cores as a thread in the real simplistic terms, so we're working with 2 to 12 parallel threads password cracking. Well, what they found out about GPUs is that they have 160 to 240 cores, and some of the newer GPUs even have more than that. And so what they found out is that they could thread those GPU applications to do parallel tasks just like they could with the processors. And so that multiplied the number of passwords exponentially that could be cracked. So what's the best technology to use? NVIDIA has support through their CUDA architecture. I'm going to stay out of all political debates about what's better. ATI support is through Stream. Both of those are proprietary formats, so the open source community, they got together and they developed a technology called OpenCL, which is open source and supports both architectures. I just like this picture. So what's better, I don't know. I use NVIDIA because, and the reason behind that is because the CUDA architecture has a lot better development. ATI cards are actually faster, however, the Catalyst, or the Stream development is not quite on par with NVIDIA as far as I'm concerned. So I like to sacrifice a little bit of speed for stability, but your mileage might vary on that one. So you all were asking about the statistics. Can't see those on my computer, but anyway, so here's a couple of graphs that show. The top one is 2 NVIDIA 480 GTXs, and you can see on NTLM it does 4 billion 30 keys per second. So that's a lot. That's only on one hash. When you add a whole bunch of hashes, like 2 million hashes, it does drop down to 2.5 billion, which is still quite a few. Sorry?
It's still less than a second, though, isn't it?
Yeah, that's per second. Anyway, yeah, so that's per second. And so the numbers are there for MD5, SHA1, MySQL. Anyway, and then so under that I have a graph of an ATI card. I don't own an ATI card. I got this from Adam. So this is on a HD 5970. You can see that one hash on NTLM is quite a bit faster on a single hash. But if you look over at the 2 million hashes, it's significantly less. So based on some of these numbers, you might want to decide, are you going to be doing 1, 2, 3, 4, and 5 hashes, or are you going to be doing lists of hundreds of thousands of hashes from a company? So like I said, your mileage may vary on cards. I use NVIDIA. Word lists. People are always asking me, where do I store all my millions of terabytes of word lists? I don't have them. You know, like I said, I have like 5 gigabytes of word lists because it's all I need. There's only so many words out there, and everything else is rule-based combinations. So I don't have a big terabyte RAID array with all this stuff. I think it's a waste of space. Using those masks that I showed you earlier is much, much more effective, and using these root words with rules. So if I have the word password and I have a rule that uppercases every letter, I have a rule that appends digits from the end, I have a rule that leets every word, you know, I have all these rules, which is much, much faster than going through a giant list of words. Also, a large word list is impossible to manage, edit, and maintain. I don't know if anyone's ever tried to open up more than a 2 gig word list in Nano or something, but it's a bad situation, I promise. All right, so this is the stuff I skipped when I was talking about my sophisticated fingerprint attack last year. I missed this stuff on how Oclhashcat actually works. And so I thought I'd go back and kind of talk about it just a little bit. This is, so initially, I'll just go through the command a little bit. The M is just the switch for the algorithm that you're going to use. 0 is MD5. And there's some other flags and stuff, and I'm not going to go all through all those because I wanted to go back to the basic part because a lot of people don't understand. It's kind of hard to get your head around. So the next thing in line is our list of hashes. And then the next 2 things is Hashcat works on what's called a left and a right mask. And so it has to do both. So there's what's it's going to do on the left side of the word and what's it going to do on the right side of the word. And so what I have here is implemented when I was talking earlier about the combination attack. So one of the things that we can do is we can take one of our cracked dictionaries that we got from Gawker or whatever, and we can put one dictionary on the left side and we can put one dictionary on the right side. And so what that will do is you can see in the little graph where I got dictionary 1 and dictionary 2. And then over on the right, I tried to implement all those words will be put together, one in the beginning and one in the end, one at the end, one in the beginning, and they'll be combinated through there. So basically, what I've done is I've taken a word list out of 6 words, and I've turned that into an infinite number of combinations that it could possibly be, and I haven't used 8 terabytes of space on my hard drive or whatever. And I got a few more examples to try to make that left and right mask make a little more sense. So here's a couple more examples. So in the first example, you can see at the end I have my left mask and my right mask. And so remember my masks, D was digit, right? So at this point what I'm doing is I'm saying take my dictionary, which is dictionary 1, and I want you to append 2 digits to the end of every single word. And so this is basically a rule that I'm given Oclhashcat. And so I've exponentially increased my word list, and I've still only got 6 words in dictionary 1 or whatever. And then this can be used in any way. And so in the next example, what I'm doing is I'm prepending 4 lowercase words, or letters, actually. I probably should fix that. So it's going to try A through Z, every single possibility, A through Z for 4 spaces, and it's going to prepend it to every word in my dictionary. So that can be effective too. And these are the kind of things that you just got to play around with and figure out which ones are the best for you. So the other nice function is that what if I want to use numbers and digits? Because remember, alphanumeric was the most popular password, so I want to use numbers and digits. You can throw it a variable. So if you can look down here, I got a 1, and I've given it lower, upper, special, and digits, so that's all 94 typable characters. And then what I do is I just use that 1 as my mask down there. So at this point, I'm saying take my dictionary word and try to prepend 2 places of all 94 typable characters to the end of the word. So that's kind of how that works. Kind of hope that makes sense to anybody. And you can play around with the place settings. You can do more than 1 variable. You can do a 2 and a 3 and give it different variables if you wanted to do something different on the left mask and the right mask. So there's also rules. I just made 2 charts of the rules. I'm probably not going to go through all of them, but I'll show you how to pass the rule. So on that same command line, we could pass it some rules even at the same time as the left and the right mask. So we could pass it the rule to lowercase, to uppercase, to capitalize. These aren't groundbreaking because John has always had rules. But there's some new ones in here that aren't exactly, that are a little bit different than John. But so some of the ones I like to use is like truncate left and truncate right, and append characters and prepend characters. Like, for example, if it's 2011, if that's the year, I always try to prepend 2011 to every single word in my dictionary, just in case it might work. So these rules you can play around with. You can pass more than 1 rule to the command. It takes the first rule first, and then it does the second rule. So there's a way you can play around with it. And the way that you pass rules is exactly the same as the left and the right. You have to pass a rule to the right side, and you have to pass a rule to the left side. You can do one or the other or both. So J passes a rule to whatever's happening on the left side. So in this first example, what's going on is I'm using my dictionary, and at the end of the dictionary, I'm appending 2 uppercase characters to the end of each word. And at the same time, I'm going to uppercase the first character in my dictionary. So that'll give me something like uppercase, 5 lowers, and then 2 more uppercases. And so if you want to pass a rule to the right side, you give it the K switch. So like in this example right here, C is capitalized. So what I'm saying is to take my 2 dictionaries and put them on both sides and capitalize the first word in each dictionary on both sides. That actually probably wouldn't be all that effective now that I think about it, because it would be a capital letter in the middle of the word. However, a lot of times I've noticed lately, people are separating words with a special character, like because everybody's talking about we got to use passphrases and not passwords. And so a lot of times people will think of a 2-word phrase or a 3-word phrase, and I've seen special characters on the inside of those phrases. So putting a special character in the middle of 2 dictionaries combinating on top of each other can be effective, and I've seen it be effective. And then, like I said, the bracket cuts off the last character cuts off the last character of the word. And so the reason that I show that, something that's funny is in the beginning there was no way with this Oclhashcat version, there was no way just to run a straight word list attack. So what you had to do was you had to do this hack here at the bottom. So what you had to do was you had to tell the K flag to remove the last character of every word. Then you had to give it your word list, and then you had to give it a character at the end in order to remove it, and then it would just use the word list itself. So that was kind of a failure in the beginning that nobody thought of. So that was a major complaint with Oclhashcat, and then the other major complaint was that there was no crypt MD5 support. And the other major complaint was that there was no support for rule files. Every rule had to be given on the command line one at a time. So instead of recoding the entire application, what happened was Oclhashcat Plus was born. It actually did away with the left and the right side mechanism. And so what it did was it can use word lists, or it can even use an entire directory of word lists. It uses rule files similar to John the Ripper, but there's a lot more rules available. And it also supports MD5 crypt. And so an example of that being run would be right here, would be the M flag, which is MD5, our hash as text. N is actually kind of a nice level. There's between 1 and 160. So it kind of depends on your GPU and the shaders and the clocks, which nice level works the best for you. For me, it's 80. Generally, it's 80 for NVIDIA and 160 for ATI. And then so now we have rule files. They're in the rules directory. It ships with a bunch of different rules, but you can get in there and make up your own rules based on any of these lists. And then you can O is just output to a file, and then you pass it a word list at the end, just like you would John the Ripper. Or you can give a slash and a star, and it will run all the word lists in that directory one after the other. All right, so what are some solutions we can look at for some of these password policy things? This talk was originally designed for something at my work, so I got to come up with some solutions. Better application coding practices, obviously. Like I said, one of the worst things is lazy coders that don't validate, certain characters in their web applications and that type of thing. I encourage all companies to have regular password audits by a third-party company. Definitely more sophisticated password policies. Increase minimum password lengths. There's no substitute for a long-ass password. I mean, there just isn't. The longer the better. Unfortunately. Another thing is to complain when you see bad policies. Every time I'm on a pen test and I see a default Active Directory policy, I always try to mention it. It doesn't always come up with the best response, but I always try to mention it. I feel it's my duty. So this stuff is dope. Where can I learn more? There's my website, Question Defense. My friend Deadwood's website right here at ob-security.info. They have he has a ton of Hashcat tutorials and a bunch of stuff on the rules and how to use them. And then obviously the hashcat.net website. You're an idiot. Where can I complain about this? If you have any questions at all about any of this stuff, you can email me, or you can hit me up on Twitter, or you can, I don't know, talk to me later. Thanks. Oh, you have a question? I'm sorry.
So you were going to create a password that you didn't want to get whacked. How would you go about that?
Number one, I would enforce passphrases. The way that I would enforce that is I would say that there has to be a special character or some type of thing separate, in the middle of the word. I would not allow the first letter to be capitals. I would not allow numbers to be at the end. I would do the reverse. That policy we looked at in the beginning said that no numbers could be separated from each other. I would reverse that. I would say you must have at least two numbers and they cannot be next to each other. It's all about, and then like I said, it's about length. Over 10 characters, making sure you use everything available.
What about alternating case between letters?
Yeah, I mean, alternating case is good. It's all about, think about the way that I like to think about it is think about what I would do as a password. And I'm just as guilty as anyone else. If it says use one uppercase letter, I'm making it the first letter because it's easier. You know what I mean? So if I say you got to use 2 uppercase characters and it can't be the first letter, that's going to force somebody to put them inside the word somewhere, which all those little bitty things added together increases the password strength exponentially.
What if you just hold shift and you design a pattern on the keys versus an actual password you're using?
Absolutely. I mean, random generated stuff is always going to be better than a password. However, getting your users, I might be able to remember that, but the problem is, it's bad policy to use your passwords in the same place all over the place. So while I can probably remember 1, 2, 3 maybe randomly generated passwords, I can't remember as many as I need for the internet totally. So unfortunately, random passwords are always better, but it's a little bit unfeasible, especially when you're talking about your user base at.
Well, then you do level of importance. So it's like
Sure.
Shit I don't care about. 1, 2, 3, 4, 5, 6. Shit I kind of care about. Slightly more complicated. Shit I really care about. 45 characters.
Absolutely, and so that's the exact same thing that I do. I have some high-level passwords, some medium, and some low-level. The problem is getting, us being involved in technology, hacking, and security, that makes a lot of sense, but that does not make sense to my mom. She could care less about any of that kind of stuff, and she uses the password, same password all over the place, despite what I say.
Oh no, I just did recovery for someone who uses the same 6-character password for everything.
Yeah, because it's easy to remember. Yeah.
Would you say a policy rule like the year that the current year cannot be in the password, or the current date cannot be in the password, or the day you joined the company cannot be in the password?
So best case scenario, this is my big idea, and so the problem is that I break into things. I don't create password policies. So if I was going to create a policy, for example, if I was creating a web application, I would go to one of those websites that has like the top 500 worst passwords in the world or something like that, and I would take that, and then I would take the year, and I would take some really, some other random stuff, because it doesn't take that long to go through a couple thousand words real quick. And then when users are input validating that, once again, I'm not a web app coder either, so I don't know how feasible this is, but I do think it would be possible to compare your password very quickly against a list of just really stupid shit. And then, you know what I mean? And if it passed the list, then it's okay.
As far as steps, if you were doing an audit or a test for company X, would you use something like the WID or strings or whatever first, or do you start at like RockU and then go from there? Like if you say I have a dump of hashes, what ends up happening is I have a dump of hashes, but do you use like RockU first?
No, I start with a brute force, because a brute force on our GPU machines takes like 5 minutes. So I get everything I can between 1 and 5 characters. And so once I get that, what I was going to show you was this fingerprint attack. If you ask me later, I have a video of it online, but it basically does a brute force of the list and expands it and then puts the 2 sides of the expanded list together and keeps cracking over and over again. You never need a word list ever. So I do all those types of things, but I always start out with a 5 to 6 character brute force to get the low hanging fruit kind of thing.
AD policy where they changed it from the default to 3 characters.
Wow.
For probably some web application. 3 characters.
Yes.
So, do you ever run into like single sign-on or simplified sign-on environments and try to crack passwords that way? What do you generally see in those types of environments?
Can you give me an example of are you talking about an application?
Yeah, so like if there's some kind of a centralized repository, and then so there's a lot of different ways to do it. Or you don't have the list combined, or no, not even that, right? So let's say you crack the AD box and you pull down all those passwords. If you're in a single sign-on type environment, you'll either have a strong complex password. The theory is, right?
Right.
You'll either have a really strong complex password that's managed by some different device, or you'll have a password that gets reset across all the systems through a central interface. And what do you tend to see in those environments as being like, do they implement it right, or
I mean, nine times out of 10, the easiest way is to manage all your devices with Active Directory, and they make it that way for a reason. You know, for example, I was just on a wireless assessment where they were had a radius implementation, which is supposed to be secure, but it's not. And so their radius implementation was using MSF Chat version 2. So as soon as I cracked the radius, not only was I on the wireless network, I already had credentials on the network, you know, because they were using AD credentials. So generally I see AD as being used across the board. So, and the bad part about that is that some appliances store those AD passwords in less complex formats like MD5 than NTLM. So sometimes you can attack that way.
For example,
Cisco, for example, if you were managing some Cisco devices, you know, their hashing algorithm is weaker than AD and can be pulled down from the
they
config.
would have it cached on the Cisco what?
Some, I've seen it before.
It would be stored in some kind of MD5 cache on like a router?
Yeah,
Or what?
in the config.
Nice.
Okay.
Sorry.
Oh.